In example 4, we need to use the following graph to answer these questions. And there seems like a lot of them. But let's just walk through them. We're going to take them piece by piece. We're going to go A, B, C, and all the way down to H. So let's take a look, and let's see if we can determine some things for A. And A says, what are the x-intercepts? So what I do is I go along the x-axis, and then I just find the points where the graph hits the x-axis. The first point is negative 4, 0. For the x-intercept, the y value is always 0. The next one looks like it hits at maybe negative 1.5, 0. And then also, we've got 4, 0. So those are all for the x-intercepts. If this is a function, there's only going to be one y-intercept. If it's not, there could be a bunch. Then I just look up and down on the y-axis, and I find where the graph crosses the y-axis. That's the y-intercept. So the coordinate is 0, 6. Remember, for the y-intercept, the x value is always 0. The next thing we're going to do is identify any maxes and mins. So if we look, we've got a minimum right here and a maximum right here. It's hard to tell exactly where this is on the graph. I think it's probably maybe 3/4 of the way from negative 2 to 3. So that's our minimum. We'll do negative 2.75, and if you use the value of 2.5 here, that's fine too. It's kind of hard to tell on the graph. And then we're about halfway down in between negative 1 and negative 2. So I'm going to go negative 1.5 here. For this one, it appears that the maximum is close to 1, so we'll try to list that as 1, and if you did 1.1 or 1.2, that's fine. And then it's about right in the middle of 7 and 8, so that'll be about 7.5. Next, we'll identify the range and domain. So the range are the possible y values. If we look up and down this graph, this side will go to positive infinity, all the values in the middle will work, and then all the way down to negative infinity will work. We want to list the range as being negative infinity, y is the variable we want, is less than infinity. This covers all real numbers. Identifying the domain, even though this graph looks like it might stop or kind of slow down here, it does keep growing. Its growth to the left might slow down, but it does keep growing to the left. We could choose any value of x here. For any value of x, even negative, all the way down to negative infinity or positive infinity, that function is defined. So we want to use x for the domain, and it turns out that negative infinity to infinity is the domain. Now what we're going to do is we're going to label the increasing, decreasing, and constant intervals. So we'll start off first from left to right, decreasing to the minimum here. So this section is going to be decreasing. We're going to increase, and then I'm just going to draw the decreasing one over here too, so I don't have to keep switching markers. So that's decreasing from this maximum down. There's a section right in the middle, from the minimum to the maximum. So from right here to right here, where we are increasing. And there's really no spot here, no interval. You could argue that the graph is constant right at the minimum and maximum, but there's no portion of the graph, no extended interval where that graph is constant. The next thing we'll do is we'll do the end behaviors. So I'm going to have to move this up just a touch, so I hope you can see that graph when you're watching this video at home. Alright, so the left end behavior, as x approaches negative infinity, we're wondering, what does y do? So to the left, the graph is going up and up and up and up to infinity. So for end behavior, we don't want to follow that left to right approach that we do for decreasing, increasing, and constant. That's only for that. As we're looking to the left, we're imagining what is the value when x is very, very negative, and the value of y will be very, very positive. The right end behavior, as x approaches infinity, what does y do? So as we increase in values of x, we decrease down to negative infinity for the values of y.